In this equation, every term has a log, so what we can do is condense the two expressions on the left into one log and compare it to the right. So when we do that, we have our common log ln, it's the natural log. Any values that came from a positive log are going to be factors of the numerator, so x plus 1 is in the numerator. Any values that came from negative logs are factors in the denominator, so x minus 2 will be moved to the denominator. All that's equal to ln of x. At this point, we can now compare the values inside the logs. So x plus 1 over x minus 2 has to be equivalent to x, and we just solve by cross multiplying. So 1 times x plus 1 has to equal x times x minus 2. We solve the resulting equation, distribute our x first. X squared minus 2x is equal to x plus 1. Move all the terms to the same side. Subtract an x and a 1 from both sides, and we get 0 is equal to x squared minus 3x minus 1. And so now it's just a matter of solving by quadratic formula or completing the square. Again, I'll complete the square here by moving the 1 to the other side. I take half of my b value and square that, giving me 9/4 that I add to both sides. That allows me to rewrite my left side as x, and then half of this first degree term's coefficient, minus 3/2, is equal to 1 is equivalent to 4/4. I can add these together as 13/4. Extract my square root. I get x minus 3/2 is equal to, you have to take into consideration the positive and negative root of 13 over the square root of 4, which is 2. Add 3/2 to both sides, and I get my solution, 3 plus or minus root 13 all over 2. When I look at this, again, I see my x can't be a negative value, so 3 minus root 13 over 2 is an extraneous solution, but 3 plus root 13 over 2 will work. So I'll go ahead and calculate that decimal equivalent. So if I take 3 plus square root of 13, I'll put a decimal in there, and I close off that whole numerator, divide by 2, I get my solution of 3.303.